Okay, so now that we talked about the levels of organization within the human body and how everything kind of assembles together, we're going to cover a bit more in depth about the different organ systems within the human body. However, it's important for us to point out that we're not really going to be covering each system thoroughly in depth within this lesson. Those particular systems are going to have their own chapters, if not more than one chapter, as we progress throughout the year and into anatomy and physiology too. So this is really just going to be an introduction, all right? We're just going to skim the surface on the body systems. So there are 11 different organ systems in the human body. This year, in Anatomy and Physiology 1, we're going to be covering the first 4 that I have listed here. We're going to talk about the integumentary system, skeletal system, muscular system, nervous system, right? The rest will be covered in Anatomy and Physiology 2. However, feel free to look into those as your interests pursue. So, taking a quick look at each of these different 11 systems and really just kind of skimming the surface, like I said, taking a chance to find out what exactly they do. This is a nice diagram, right, pointing out the specific makeup of these different systems and kind of pointing out some key organs within the systems. All right. It's important for us to acknowledge, again, that organ systems are focusing on specific organs working together for specific functions, and that linking in that homeostasis, right? Homeostasis really depends on organ systems working together, right? The idea that the nervous system is going to have a lot of control over other systems, right? That the circulatory system is going to play a role in transporting oxygen. But in order for oxygen to be transported appropriately, your respiratory system also needs to be functioning correctly, all right? So it'll continuously link together all of these different systems as we progress through the year and we talk about each of the systems in depth, right? I'll try to make connections as we go so that you can see how it is that all these different organ systems really work together like I'm talking about. So when we look at the integumentary system, right? Integumentary system, we're really talking largely about the skin, all right? So we're talking about the skin. We're also including hair, nails, sweat glands, all right? Sebaceous glands. Sebaceous, what I'm referring to, talking about oil glands, all right? The oil glands that secrete oil for your skin. The skin, right? The integumentary system is actually the largest system, right? Because the skin is actually the largest organ in the human body. Think about the surface area that the skin really covers. Nothing else can compare. All right? There's tons of different functions for the integumentary system. All right? A really big one is protection. All right? Integumentary system protects you from the outside world. Think about how many different pathogens, bacteria, viruses you come in contact with on a daily basis. How many potentially hazardous chemicals, right, that you potentially may be coming in contact with. That first line of defense, right, which is often referred to as, that first line of defense is really your integumentary system, your skin, all right, making sure that your internal environment is not coming in direct contact with the external environment on a day-to-day basis, all right. In addition, the integumentary system is going to play a role in regulating your body temperature. We know that sweating will occur versus shivering, but it's important to point out that although the integumentary system is playing an important role in maintaining body temperature, we should also know that sweating is going to have a connection directly to our circulatory system, right? The idea that the circulatory system, those blood vessels, are going to dilate and constrict as necessary based on body temperature. Likewise, shivering is going to have a connection to the muscular system, right? When heat needs to be generated, muscle contractions creating shivering will occur. So making that connection between different systems working together to ultimately maintain that homeostasis, right? Many of your receptors are located here. Obviously, tactile receptors, all right, touch, pressure, all right, thermoreceptors, being able to receive temperature input. So there's all these different receptors, nerve endings, that are often going to be located in your integumentary system. So here's a picture of the integumentary system and what it is that we're talking about. We're really just talking about the overlying skin, the hair, the nails, and such. The skeletal system, right? Not only is the skeletal system talking about bones, but we're talking about ligaments and cartilage, right? Ligaments are the particular structures that are connecting bone to bone, not to be confused with tendons, which are muscle to bone. So ligaments are connecting bone to bone, all right? Our functions of the skeletal system, huge, huge three. Support, all right? This is structural support. Think about what your body would be like without your skeletal system. There'd be nothing to hold your body upright, right? Your organs would just be a big giant pile. Your skin would just be a big giant overlying layer, right? There'd be no real organization. Limbs and such wouldn't really have their shape, all right? So structural support, we're talking about shape as well, right? Protection, right? Think about the strength that those bones provide. Movement, right? The ability for you to be able to transport yourself, to locomote, to go from one place to another, right? Blood cells are actually produced within the skeletal system, within bones, right? So there's tons of different functions for all of these systems, and it's important for us to acknowledge that it's not always the first thing that comes to mind being the only thing that they're responsible for. I'm sure that you don't typically think about mineral storage when you think about the skeletal system. Picture of the skeletal system really just outlining, right, what it is that we're referring to when we talk about the skeleton and those bones. The muscular system, all right, our muscular system, we're talking about skeletal muscle tissue, right? We're not talking about cardiac muscle tissue, right? We're not talking about smooth muscle tissue. We're talking about skeletal muscle tissue, right? Contractile properties for movement, right? Maintaining body position. This is huge. Something that you probably don't even know, that when you're standing still, your muscles are constantly working to actually keep you in that still position. They're sensing the slightest little change in your body position, and they're contracting and relaxing in order to make sure that you don't have these massive sways in your stance. When you're standing totally still, all right, your muscles are always contracting, relaxing, and really paying attention to how much adjustments need to be made so that you're not just standing there swaying back and forth. They're really regulating your body position. Producing heat, we know, we talked about shivering already, right? The idea that that muscle contraction can really generate some heat for the body. So here's a pretty basic picture of the muscular system, right? And we can see how it's, you know, spanning everywhere within the human body because it really is playing a role everywhere. The nervous system, all right? Brain, spinal cord, peripheral nerves, sense organs, right? All these different things. We tend to think about the nervous system when we think about the brain and spinal cord, right? We rarely really focus or think about sense organs, right? The particular things that are responsible for sensing all of these different changes in the environment. So we have, in the nervous system, we've got nerve impulses, all right? The proper name that we're going to be referring to as we cover the nervous system in depth is going to be action potentials, right? And action potential is really referring to the nerve impulse, how that message travels, right, along the nervous system and through the different nerves in order to communicate, right? Interpreting changes, right? Acting upon those changes. That's really that receptor effector discussion that we had in homeostasis. So the nervous system plays a huge role in maintaining homeostasis because it's constantly receiving information from everywhere inside of your body as well as outside of your body. So it's going to be responsible for communicating a lot of that information throughout the rest of the systems so that they can operate properly and make any corrections as necessary. Nervous system image, you can see how the nerves are really, again, just like the muscular system, spanning everywhere. You have your main central nervous system, right? We're talking about brain, spinal cord, but communication needs to occur. It needs to occur right out to the tip of your pinky, right? And it needs to occur right out to the tip of your big toe. So it's important for those specific nerve endings to really be reaching out to the furthest locations within your body. The endocrine system, right? Endocrine system is really your hormonal system, right? It's glands that are producing all of these hormones, your pituitary gland, thyroid gland, etc. Ovaries, testes producing some of your male versus female hormones, right? So it's important for us to recognize that hormonal changes are responsible for a lot of different controls, a lot of different body reactions, right? Those hormones are going to be created by these organs, then they're going to be transported through the blood. So again, we're making that link to the circulatory system, that the endocrine system relies on the circulatory system to actually transport its product, right? It really actually can't get its product out to the consumer, right, to the rest of the body without the blood, without the circulatory system doing the shipment for it, right? And then it's going to travel to those target cells, whatever specific cells are in need of those specific hormones in order to create the response that the body is looking for. So we look at a picture of the endocrine system, we're looking at all of our different glands and where they are in reference to the rest of the body. Our cardiovascular system, right, circulatory system like I was talking about, right, our cardiovascular system, blood, heart, blood vessels, right, we're talking about distributing oxygen, distributing nutrients, such a vague word. We're talking about carbs, we're talking about lipids, specifically, that's when it comes to food, but when we're not just talking about food, right, there are other things that get transported. We've got hormones, cholesterol, technically a lipid, is going to need to be transported. So carbs, lipids, we've got proteins, minerals, vitamins, these quote-unquote nutrients, right, that need to be transported. Wastes need to be carried away. Most common waste that we always typically think about is carbon dioxide. All right, the maintaining an acid-base balance is really about the oxygen and carbon dioxide levels and making sure that the blood is not containing too much of one or the other, or it could potentially become acidic or basic, alkaline. So it's really about making sure that oxygen that's being brought into the body is being utilized by the cells, carbon dioxide that's being produced by the cells is being removed from the body, right, by exhaling. So it's important to maintain that balance. Protecting against disease. We know that we've got white blood cells that are fighting our dirty work for us, right? Repairing injury, we've got clot formation like we talked about before. That clot formation, we talked about it being positive feedback mechanism that's deviating from homeostasis, right? That's stepping away from the norm. Regulating body temperature. There's all these different roles. Cardiovascular system or circulatory system really has a huge role because it's really responsible for helping a lot of the other systems do their jobs as well. Cardiovascular system, we can see that, again, just like the nervous system, just like the muscular system, right, that these blood vessels are really going to be traveling all over the body. And if you look, we can actually look into like size. Look at how large some of our blood vessels are in the central area of our body, in our thoracic cavity, right, as well as our abdominal pelvic, right? We still have pretty large vessels there as well. Versus if we get out into the smaller areas, the vessels obviously are going to be smaller. Large amounts of blood being needed versus smaller amounts of blood being needed.